Okay, in today's class we are going to discuss about the disadvantages of linear queue. So disadvantage of linear queue and how you are going to overcome this disadvantage. So the first disadvantage is, you all know where you are going to insert the element. We are inserting the element at rear end and you are deleting the element at front end. So first disadvantage is, item cannot be inserted from the front end even this when the space is available. If the front end, if you have deleted, there will be a empty space on that. So you can't insert the element there because deletion will be done at the rear front end only. You can't insert the element at front end. That is one of the disadvantage of linear queue. Okay. So second one, items cannot be deleted from rear or middle. So there are two ends. So first disadvantage is item cannot be inserted from the front end, and second one is item cannot be deleted from rear end. So that is the two disadvantages you are having here. So how you overcome these disadvantages? So the linear queue disadvantages can be overcome using the concept called circular queue. So circular queue will be, the queue will be in linear queue, it was in the form of a straight line. So you can see here, so how see this linear queue, how you are having, it is in the form of line. So, but you come for linear queue is in the form of line, but circular queue is in the form of a circle. Okay, so you can overcome the disadvantages of linear queue. Use what are the disadvantages? Item cannot be inserted from front end and item cannot be deleted from rear end or middle end. So leave this middle. So for now, there is only one, that is item cannot be deleted from rear end. So these are the two disadvantages you are having. So this can be solved using circular queue where front and rear are adjacent. So keep in your mind. So this can be solved because in circular queue, the front and rear are adjacent when queue is full. So when the queue is full, the front and as well as rear both will be adjacent. That means, so after the rear, you will be getting front. So when there are adjacent, they will be adjacent when queue is full. If any item is deleted, then variable rear can be used to insert item. Understand this one very carefully. So how you solve the circular disadvantage means by using circular queue when front and rear end are adjacent when queue is full. When the queue is full, if any item is deleted, then variable rear can be used to insert the item to utilize it. Okay. So what is the definition? So definition of circular queue. So circular queue is a linear data structure in which operations are performed on FIFO. So you all know queue will go with a FIFO. That means, so first item in the queue will be the first item to be deleted from the queue. So first item inserted into the queue, Fi. Fi means first item, first insert, first out. First in, first out. So first element inserted will be the first element to be out or deleted. So this is the principle, and last position is connected back to first position to make the circle. So keep in your mind. So last position means, so keep in your mind, the last position is rear. So last position is connected back to front position. So front position means it is front. So first position is nothing but front to make a circle logically. So this is the concept. So what is the circular queue? If they ask you the definition of the circular queue, it is a linear data structure in which operations are performed on FIFO and last position rear is connected back to first position front to make the circle logically. So there are two terms here. So here we come across two terms. One is NQ. So NQ is nothing but inserting the element. Okay. So similarly, you will be having dequeue. So dequeue means delete the element. So these are the two terms what you are going to use it here. One is the enqueue used for insertion, and the second one is dequeue going for the deletion. So this is the form of the circular queue. So are you able to see the diagram? Are you able to see the diagram? So have a there you can go for the terms NQ and DQ. So it is given there. Only one is replying. What about the others? Are you able to see the diagram, right? Okay, so there are two words. One is NQ, the other one is DQ. NQ means you are going to insert the element into the queue. The other one is DQ. DQ means you are going to delete the element from the queue. Okay, so first you come for the first one. So this one is, it is NQ of 14. So there is a queue, this is the queue, and first element is 14. Okay, so this is the first element you are inserting. So this will be the first element. Come for the second element. So where is the rear? Rear is here. Where is the front? Front is here. So initially when the queue is empty, both front and rear will be at same position. So understand carefully, when the queue is empty, front and rear will be at the same position. But when you insert the element, so front will be pointing to the element and rear will go to the next place. So where is the rear is pointing now? Rear is pointing to second location. So come for the second location, we are having 22. So where is front? Front is at 14 and rear is at 22. So next you are NQ of 13. You are inserting the elements. Next you are going for NQ of minus 6. So minus 6 is coming here. Now you come for the word DQ. So you are coming for the word DQ. DQ means what? So you are at deletion. So deletion will be done at front end. So which element will be deleted? So rear is pointing to minus 6 and front is pointing to 14. So now you see here you have applied DQ. DQ means 14 element will be removed. So see, you can see here. So 14, next you will get 22, but here you see when you apply DQ, the element 14 is not there. Element 14 is been removed here. So come for the next one. Again you apply DQ. That means after 14, which is the next element, you had 22, that 22 has gone here. So front is at 13 and rear is at minus 6. So now I am going for the new one, NQ of 9. So NQ means you are inserting at the rear end. So where the rear is there, rear is at minus 6. So you are going for one position. So now rear will be pointing to 9. So because you have inserted the value 9. So come for here, next NQ of 20. So similarly, you are going with inserting the element is 20. Okay, so again you are going with NQ of 5. So NQ of 5 means again you are having this one. Now you see where is the front end and where is the rear end. Okay, so front means where is the front? You were having it at 22, 22 you have removed. So now what is the element? 13. 13 is not removed. So front will be at 13. But when you go for the insertion, where you will be rear end? Rear end will be at 5 and front end will be at 13. So when the both are next to one another, now we tell that, sir, this queue is full. So keep in your mind, when you tell the queue is full, when the front end and rear end are side to each other, when both are side to each other, that means adjacent, then we tell the queue is full. Understanding? Understood this concept? So can you tell when the queue is full? When the queue is full in circular queue. Front end, rear end, or adjacent. Okay, front and rear end side each other. So you are correct. So now you come for the next concept. So coming for the next concept. So what is the circular queue? This is the continuation of that. So continuation of that, one item is deleted from front end and queue of 0 is, you see, this is a circular queue. So circular queue, so this is location 0, 1, 2, 3, 4, 5, 6, 7. So when, what is the main advantage? You have to insert the element when you delete the element. So if the space is there also, if the space is there in front, you are not able to insert in the front end. So that is one of the disadvantage. So that you have to overcome using circular queue. So kindly understand this one. So item cannot be inserted from front end, even the space is available. So that one we are discussing here. So you have deleted the element which is at 0th location. The space is empty, but you cannot insert the element here because you can't insert it in the front end. So in this linear queue, but you can insert, okay, but you can insert in the circular queue. So now you see here one item is deleted from front end. So which is the element deleted? It is at location 0 and that is been deleted, and now front is pointing to 1. So one item is deleted from the front end and Q of 0 is, what is there in Q of 0? Q of 0 is been deleted and it is vacant. Now front is equal to 1 and rear is equal to 7. So rear variable, it can be occupied. So rear variable can insert the element here. Okay. So that is the, now you can insert the element in the rear end. Okay. So what is the front end? Front end is at 1. What is the rear end? The 0 will go for the rear end now, because front end will be pointing to 1, which is the empty one. Empty one is 0. So this will be occupied by rear end to make the element insert. So this element can be, rear end will be occupied by the Q of 0. So now you come for the very important one, circular queue operations. So what are all the operations you can do in the circular queue? So first one, front end, rear end, insert queue, delete queue. Okay, so other one, display will be always it will be there, but important functions are insert of queue and delete of queue. So what are all the operations on circular queue? So first one is front end. What you do at front end? Delete the item from the front end. At rear end, insert the item at the rear end. So insert of queue. Okay, so insert of queue means you are inserting an element into the circular queue. So function is used to insert the element in circular queue. The new element is always inserted at rear position. So in circular queue, the new element will be always inserted at rear position. So for that, what are all the conditions and what are all the steps? So if you want to insert the element, so first check whether the queue is full or not. So the first step is check the queue is full or not. So that we call it as overflow. So this is queue overflow condition. So in circular queue, how to check the queue overflow condition? So first condition is normal. If rear double equals size, So you have here you have to there in linear queue you were going with rear double equal size, but here you have to go with both rear and front. If rear double equal size and front double equal 0, that means rear will always start at location 1, 2, 3. Front will be the first element. First element will be 0. So now you have to, for queue overflow, you have to check both rear and front. What is the condition? Rear double equal size and front double equal 0. Or this is the or symbol. Rear double equals front minus 1. So for rear, how you represent when the queue is full, rear and front will be beside the side only. So how you check? If rear double equals front minus 1, that means if rear double equals front means no problem, that is also a scenario. If rear double is equal to front minus 1 means rear is at one position, next position it is a front. So if rear double equals front minus 1, then we tell it as queue is full. Okay, so if queue is full, what you will do? Display queue is full. If queue is not full, so when the queue is not full means rear double equal size minus 1 and front not equal to 0. So front not equal to 0 means the element is there. There is a space. So you can insert the element. So this is the condition. So what is the condition for queue full? So if rear double equal size and front is equal to 0 or rear double equals front minus 1. So either you can go with this condition or you can go with this condition. So two conditions. So that is for queue is full. So if the queue is not full, to insert what you will do? Check rear double equal size and front not equal to 0. So then you can, if front not equal to 0 means there is some space, so you can insert the element. So that is the condition. Now you come for the delete. Delete is used to delete an element. The element will be always deleted from which end? Front position. So first step is for checking the queue is empty. How to check the queue is empty? By using front double equals minus 1. So initially when there is nothing, front and rear will be pointing at minus 1 only. If there are no elements in the queue, the front and rear will point to minus 1 only. So that will mark if front and rear are at minus 1, there is no element in the queue. If it is empty, what you will do? You will display the queue is empty. If the queue is not empty, go to step 3. So this is a step 3. So if check if front double equals rear. If front and rear are both, then set front is equal to rear is equal to minus 1. Okay, so if there are no elements, what you will do? So front and rear will be at same position. So at that time you are going to set front is equal to rear is equal to minus 1. Okay, that means if there are no elements, there is nothing. So that will be checked using front double equals rear. Else, if there are not same, that is front double equals size minus 1. If front double equals rear, set to minus 1. If front double equals size minus 1, set front is equal to 0 and return that element. So how you calculate the front and rear? So how you calculate the front and rear? That using this formula, front is equal to front plus 1 mod size and rear is equal to rear plus 1 mod size. So you have to understand carefully here. So first condition for queue overflow is if rear double equals size minus 1 and front double equals 0, the queue is full. If you want to insert, what you have to check? Rear double equals size and front not equal to 0, then you can insert the element. Come for the delete. So when you tell the queue is empty, when front double equals minus 1, or when if you want to delete, what you will do? Check when the front double equals rear or front equals size minus 1. So these are the conditions for circular queue. So now you come for the operations in detail. So this is the circular queue operations. Insert and delete operations we are going to see it here. So initially you see I'm taking the max of size as 10. Front is equal to -1, rear is equal to -1. So when front and rear is equal to -1, what is the thing? So Q is empty. So this is the condition to tell that Q is empty. When front and rear both are at -1, Q is empty. Come for insert. So insert of uh, item into the array. So array comma item. So what are all the conditions for full? So what are all the conditions we have seen here? If rear double equals size -1 and front double equals 0, or rear is equal to front -1, same thing you can see here. Rear double equals size, in place of size you are having max -1, and front double equals 0, or you can take it rear double equals front -1, both are same. Front rear double equals, move this +1 onto that side. So rear double equals front -1 means the queue is full. That means rear +1 is equal to front, you can take it. If the queue is not full, come for this inserting the elements. So how you insert? Rear is equal to rear +1 percent max, array of rear is equal to item. This is the two steps what you tell for. First, you make the space for increment the rear and place the item. So same conditions. This one is for what you can tell, increment rear. Okay. So now what is the second step you are having? After incrementing, what you will do? Place the element. So two steps you are having. So how you increment the rear? So rear is equal to rear +1 percent max, and then you place the element. Array of rear is equal to item. That is for placing an item. If front double equals -1, set front is equal to 0. That means when Q has been inserted an item. So first time if you are inserting an item, what will be the condition of front? Front will be at -1. So you have to make it 0. Okay. So similarly come for the delete. So first you check for your delete means this one you can take it as element ELE. Okay. So first you check for empty. So when you check for empty, when front double equals -1, you check it for empty. So put as Q is empty. If not, now you see you are going to delete. So ELE is equal to array of front. You are placing the element, front element is been made 0. Okay. So similarly, you have to check if you keep on deleting all the elements, what will happen? If you keep on deleting, if you keep delete all elements, what will be the case? Front double equals rear. So at that time, front is equal to rear is equal to -1, else front is equal to front +1. This is the condition. Okay. So front is equal to front +1. This is the condition for delete operation. Understood? Understanding? Understanding? Use this particular link for attendance. So now you come for the program, complete program on circular queue. So complete program, first we have gone with the operations, size is 10 and rear and front are -1. So rear and front are -1 is what you can tell, Q is empty. So now you come for the add. First you check for the Q is full. Same conditions we are writing here. So this is for inserting the elements. So similarly, you go with a delete, friend double equals -1, q empty. Now you set the data and make it 0. If friend or rare or both equal, what you will do? Friend is equal to rare is equal to -1, you can give it. Okay, so come for the display operation. So display printing all the elements. So print, this is the code what we take. Start from the 0th location less than max I plus plus. So this is for printing all the elements. So now you come for the main function similar to linear queue. The same thing, no change in linear queue. So main function will remain same. Only change you are having is add queue and del queue. So there also we have taken while first option for insert, 2 for delete, 3 for exit. So first ch double equals 1, choice is 1 means insert. So enter the data to insert. So this is the calling function you are calling. So this is the calling function add, and once you add you are going with a display. Else if ch double equals 2, you are calling del q. So del q of q will delete the element and it will display. So similarly, if ch double equals 3, break means it will come outside the loop. Understood? So come for the insert string of all the elements. So this is the output you can see. So first you have, inserted so many elements. So 11, 22. So now you have gone with the first option, that is 2. So first option 2 is delete. So which is the element deleted? It will be 11. So now it will point to 0. So now again I have chosen 2. So it will delete 22. So once you delete, you are getting it as 00. Now I am going for the insert of 1, that is 88. So 88 means it will be inserted at rear end. So after 77 it was 0. Now you see after 77 it is 88. Now I am again going for the insert, that is 99. So 99 means after 88 0 you will get 88 99. So again insert the element 111. So inserting the element means where is the rear end now? Rear end is at 99. Where is the front end? Front end is at 33. Okay, where the element is there, there only the front end will be there. So here no elements, 00 vacant. So front end will be at 33, rear end will be at 99. So still how many places are there? 2 zeros. So now I am going for the insert, that is 111. So where this 111 will come? 111 will come in the first position. So here it is 00. Now you see here you are having 1110. So this is the operation on circular queue. So this is the operation what you take on circular queue. So now you come for the review questions. So answer for these questions. So linear queue, when the queue is empty, answer for these questions now. When the queue is empty and when the queue is full, and so give the answers for this. When the queue is empty in linear queue, yes, answer for these questions. So when you tell the queue is empty, when the queue is full, if friend double equals rare, not equal to null means, what is the answer? So tell me the conditions. When the queue will be empty, if front and rear are found in linear queue, you have to see if the front is at -1, we tell it as queue is empty. When the queue is full, so queue is full when we have front, rear double equals size -1. So rear double equals size, so then we tell it as queue is full. If queue double equals rear not equal to null means, what is the meaning of that? If front double equals rear not equal to null means there are elements in the queue. If front double equals rear not equal to null means there are elements in the queue. Come for the circular queue. So when the circular queue is empty, when front when the front and rear are -1, front is equal to f is equal to r is equal to -1, where then we tell it as q is empty. When you tell the circular q is full, when we have front rear double equal size -1 and front not equal to 0, so at that time we tell it as circular q is full. So this will be the these are the answers for the review, and if you want anything, you can refer to this particular video link, YouTube video link also. Okay, so YouTube video link will be shared there. So this is up to circular cube. Okay, so I will be ending this particular session. Thank you all.